A 10-foot long ladder rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So let me make a little bit of a diagram here. So here we have our ladder, and it's leaning against a wall. And we need to start filling in quantities. We have a right triangle, which is really nice, right? We were told that the wall is vertical. So we have a right triangle in there. And that's going to give us a nice relationship. Do we know any of the lengths of the sides of the triangle? Well, we're told that the ladder is 10 feet long. And that is a constant. The ladder is always 10 feet long. It's not going to get longer or shorter. So we can label that side of the triangle, the hypotenuse, is 10. But because the ladder is going to be sliding downwards, we know that these other two quantities are going to change. They're functions of time. So we can call the height y or y of t, either way. And we can call the length, the bottom of the triangle, x, or x of t. You can really write them either way. I'm going to write them out very consciously as functions of t, just so that we remember that these are quantities that can change. They are functions of time. Now, once we have those written, we do have a relationship between those three quantities. This is a right triangle. So the Pythagorean theorem tells us that x squared plus y squared equals the hypotenuse squared. 10 squared is 100. And so this is the equation that relates those three different quantities. Now remember, once we have an equation that relates the different quantities, we use implicit differentiation, and that will give us a relationship between the rates of change. So we want to differentiate both sides of this with respect to time, because these are functions of time, remember. So we've got the derivative of x squared plus y squared equals the derivative of 100. Now the derivative of x squared is 2x, except, remember, we're differentiating with respect to time. So we have to use the chain rule and multiply this by dx over dt. And then similarly, when we differentiate y squared, we get 2y, but times dy over dt, because that's also a function of time. And on the right-hand side, the derivative of a constant is just 0. So we have our equation. We can divide both sides by 2 just to simplify things a little bit. I like getting rid of extra coefficients that aren't necessary. Just makes things a little bit nicer. And then we have to think about what we want to find and what information we have. What we're asked is to find how fast the top of the ladder is sliding down the wall. So that's dy over dt. So we need to find that. The question is, do we know the other values? Well, we're told that the bottom of the ladder is sliding away from the wall at a rate of 1 foot per second. So that is actually moving this way, which means that our function x of t is increasing at a rate of 1 feet per second. So that means dx over dt is just 1. And it's a positive 1 because when that ladder slides, that distance grows. Now, we also need x and y. And the information we haven't used yet is that we're looking at all of this specifically when the bottom of the ladder is 6 feet from the wall. So at this moment, x is equal to 6, right? I'm going to draw another little diagram down here specifically for the moment we're looking at. X is 6, and then this is 10. And we're not told what y is, but again, we have a right triangle, so we can actually figure that out. We've got 6 squared, which is 36, plus y squared equals 10 squared, which is 100. If we subtract 36 from both sides, that gives us y squared is 64. And when we take the square root, y is 8. So we know at this moment y is 8, so we can plug that in. So notice here that we had an equation that had multiple unknowns, but we actually knew the values of each of the unknowns except for the one that we needed to solve for, and that's going to be what lets us figure out our answer. 6 times 1 is just 6, and what we're going to do is we're going to subtract that from both sides to move that term to the right. So that's going to be 8 times dy over dt equals negative 6. And then we divide both sides by 8 to get our dy over dt alone. So that's negative 6 over 8, which is the same as negative 3/4. And we were asked, how fast is the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Well, this is a speed, and our measurements are feet and seconds. So this is going to be feet per second. And so it is sliding down at a rate of 3/4 feet per second. The height is decreasing. So if we're talking about the rate of change, the rate of change is negative 3/4 feet per second. But they're just asking how fast is the top sliding down. They're asking just for speed. So you could say 3/4 feet per second because they're already saying it's going down the wall in the wording. If this problem was in a homework system online, I don't know if they would be looking for negative 3/4 or positive 3/4. Hopefully they would specify, but basically it is sliding down at a rate of 3/4 feet per second, at least at that moment.